This video is on the objective solve linear trigonometric equations in sine. Alright, so in this video you're going to be seeing linear trigonometric equations. And just like linear polynomial equations, that just means you're going to have a single trig function. In this case it's the sine function show up. And the highest power on that sine function you're going to see is the first power, right? It's linear. And you solve these in a pretty similar fashion to how you would solve a linear polynomial equation. It's just there's a little extra after. So let's take a look. Alright, so again, if you're unfamiliar with the topic, want to see more about what they have to say about it, click on More Instruction. Look at their videos, their notes, their examples, and hopefully those help you out. Alright, so the question is this. If, theta, some angle theta, ranges from 0 radians to 2 pi radians, equal to 0 but not equal to 2 pi. So from 0 up to 2 pi but not including 2 pi could be the possible values of theta. And then we have this linear trigonometric equation in sine. Again, notice it's linear because it's got, a number times sine to the first power plus some other number equals some other number. It's just like ax plus b equals c with polynomials, but instead of the variable being x, the variable is theta, and you have the sine of theta. Right. Determine the values of theta. Right. Solve this equation. Find all the values of theta from 0 to 2 pi that make this true. All right. So let's write this out on some paper. So again, just making sure that we understand the range of theta here. Right. Theta has to be from 0 to 2 pi. And the equation is this, negative 10 times the sine of theta, pardon me, plus 2 equals 2. Alright, and like I said a minute ago, solving these linear trigonometric equations, in one function, in this case it's in sine, this is like solving negative 10x plus 2 equals 2. It's just like that. But instead of x, I have, the sine of theta. So you know how you would solve this. You would get x alone. Same here. Get the sine of theta alone. And we'll isolate the sine of theta. So first I would be subtracting 2 from both sides, right? Leaving me with negative 10 times the sine of theta equals 0. And then dividing by negative 10. Right? And I would divide by negative 10 on both sides. And we now have what I want. I want the trig function alone on one side and some number on the other. Well, 0 divided by negative 10 is still 0. Alright, so now that I've isolated the trig function, I want to think of what are angles, that have a sine of 0. Now, what I'm going to write here next is what's called the general solution, because you're going to notice that if these trig functions, if these trigonometric equations have solutions, they're going to have infinitely many, and then we're going to cut it down to the solutions that are actually in the range that we want. So I think of the general solution. I'm going to be describing every possible theta, every possible number I could replace theta with and make this true. Now, if you do think once around the unit circle, right, remember the unit circle, I could replace theta with, remember the sine of 0 was 0, right? Theta could be 0, right? The sine of 0 was 0. And then you're going to see this quite often. Remember coterminal angles? If the sine of 0 is 0, all I need to do is add 2 pi and get another angle with a sine of 0. If we're talking radians. If you're talking degrees, you just add 360 degrees and you get another angle with the sine of 0. Those coterminal angles, those angles that end in the same position. So something you'll see very often is, you find one angle that has a sine of whatever, a sine of 0 in this case, and then you just add on 2 times pi times, say, k, where k is an integer. Right. So 0 makes this true, right? The sine of 0 is true. If k is 1, you'd have 2 pi. The sine of 2 pi is also 0. If k is 2, that'd be the sine of 4 pi is 0. That's true. If k were negative 1, you'd have the sine, the sine of negative 2 pi is 0. That's also true. So this gives me a description of like all possible angles that are coterminal with the angle 0 that have a sine of 0. Also, though, right, remember, if you go once around the unit circle, an angle of 0 radians isn't the only angle with a sine of 0. Pi radians also had a sine of 0. So theta could also be replaced by pi. The sine of pi was 0. And then I throw on here any angle coterminal with pi radians. So again, this plus 2 times pi, plus 2 pi times k, where k is an integer. All right, so what I've just written here, again, is called the general solution. All right, it's a description of all infinitely many solutions to the equation. All right, but now, remember the beginning of this, they only want values of theta from 0 to 2 pi, but not including 2 pi. So then something else I like to do is, start listing some solutions here. Now, k is an integer, so if k were 0, I'll get 2 solutions, one from each of these. What if k were 1? What if k were 2? And so on. What if k were negative 1? What if k were negative 2? And so on. And then what I'm doing here is I'm just listing solutions. Now you don't have to do this. You can probably already tell me that 0 and pi are the only solutions from 0 to 2 pi that they want. But when k is 0, right, again, you get theta equals 0, theta equals pi. Right, those are some solutions. When k equals 1, add 2 pi to this, you get 2 pi would work. Add 2 pi to this, 3 pi. When k equals 2, you get 4 pi from that top one. 0 plus 4 pi, and then pi plus 4 pi is 5 pi, and so on. Right? And then going backwards, negative 2 pi when k is negative 1, and when k is negative 1 here, you get negative 1 pi. And then, when k is negative 2, negative 4 pi from the top equation, negative 3 pi from the bottom one. Can you see how, I could do this forever, but can you see how, like, every multiple of pi is a solution to this equation? Right? The sine of any multiple of pi, 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, negative 1 pi, negative 2 pi, negative 3 pi, negative 4 pi. Those are all solutions to this equation. But, right, they only wanted the solutions that satisfied this statement here. And the only solutions that satisfy that statement are these two. Right? So the solutions that they want, they want theta equals 0 and theta equals pi. Right? And you can check, right? Or just, again, the sine of 0 is 0, the sine of pi is pi. Or go back to the original equation even. If I plug in 0 for theta or pi for theta, it'd be negative 10 times 0 plus, which would be 0 plus 2 is 2. And then plug in pi, negative 10 times the sine of pi, will add 0 again, plus 2 is 2. They both work. And then all these solutions are too big. All these solutions over here are too small. Right, these are, again, the only two in the range that's described. So that's this third option. Wonderful. Okay. Alright, so hopefully watching me do this. Now this, I did a little more than you probably need to. The listing of the general solution, describing all infinitely many solutions, and then listing a bunch of solutions, and then picking out the ones that match the range that you want. You probably won't have to do all that in most cases, because usually they're going to ask you for solutions from 0 to 2 pi, which are pretty easy to find if you know your unit circle pretty well. But I'm going to continue to do this though. State the general solution, make a list of a bunch of solutions, and then find the ones that are in the range that they want. Alright, so hopefully watching me do this helps you, and looking at the more instruction, the answer explanations, hopefully all this stuff helps you out when you're working on this stuff on your own. And thanks for watching.